Okay, so our first exercise, this is something that I've put on every exam one and usually on the final exam as well, is a contingency table where I ask you to make some conclusions or calculate some percentages from it. All I want to see is that we know how to read this contingency table and how to talk about the values we could get from it. So what I'd like you to do, for those of you guys from my hybrid class, go through these first 3 questions and just go ahead and calculate what you think the percent is. And you do not need to actually get out a calculator and figure out the percentage. I just want you to put down the fraction before you watch the rest of this video. So pause now and put down the fraction that you think is the correct answer for each of these problems. Okay, so you should have paused the video. I'm going to keep badgering you about that because, as I said, you're going to be much better off come exam time if you've tried these problems on your own and figured out what your misconceptions were than if you just wait for me to tell you what the right answer is, because then it seems easy and you don't realize you're going to make mistakes. So if you didn't pause it, you have one last chance to pause the video now. All right, so I'm assuming everyone has numbers down here. What percent of all cars surveyed were European? So here, the only thing we mentioned is that the cars are European. We have nothing about the type of driver, whether they're student or staff. And we have a nice thing telling us that we're looking for the percent of all the cars. So all cars is our total, right? Our whole, and that's 362. And then the European cars, they're in this row. And as we just built that other table, we realized we don't care about the 33 for student and the 15 for staff. We want all European cars, that 48. All right, I'm just going to go down the row and then I'll put in the percents. So what percent of American cars were owned by students? So now we have 2 things mentioned. We have student and we have American. But as you'll notice, now the wording has changed. Instead of saying of all cars, it says of the American cars. So the whole that we care about are these American cars. We can ignore the rest of this table. We only care about that. And so our total, what we're dividing by, is that 212. And we want, of those American cars, how many were owned by students? So now we're going, okay, of the American cars, 108 of them were owned by students. All right, and the last one is the one that most people have trouble with. We see Asian, staff, and again, we can kind of see right here, we got Asian, we have staff on our table. We can be pretty confident that our numerator is going to be where those 2 things intersect. It's going to be that 46. But the majority of mistakes happen here by thinking that we're going to divide by the 165 or the 102. In reality, if we read this little carefully, I should have underlined these in blue like I did on all the other ones. It says what percent of cars were Asian and owned by a driver. So this is actually implying that we're talking about all cars still. And a big hint for this one is you see the word and. The and is telling you these 2 things are linked together. This is the outcome or the part of the whole that we're interested in, and this is the whole. So as soon as you see that keyword of and, we're going to divide by the overall total. This is English crap, right? So we're going to divide by your overall total if you have the and. All right, so 2 last things I want to talk about on this problem before we do the conditional contingency table. One is calculating those percents, because this is a common mistake I see from students and a huge pet peeve, and I dock a ton of points for it. And that is, if I were to do this in my calculator, I get out 0.1326. Now, some textbooks go into like a lot of different things about, oh, if you're doing this, you need to keep 1 more decimal point than was in the original data. If you're doing this, you want to have 2 more decimal points. I think that that's just a pain in the ass. We're going to leave significant figures to chemistry. That's their job. And I'm just going to say we round everything in this class to 4 decimal places. So I'm going to stop here. In my calculator, by the way, because a lot of students have trouble with rounding, this is what I have. Since that's bigger than 5, we're going to round up and get 1326. All right, it does not ask for a decimal though, it asks for a percent. So one last step, I need to write 13.26% because I'm going to multiply by that 100% and move my decimal place 2 places. My pet peeves are students doing this when they want to make this into a percent. Oops, I forgot to. Just throwing a percent on the end. this has a very different meaning. This is a really, really unlikely, really, really small thing. So if you do this, I'm going to dock you extra points because I'm angry. So don't do that. All right, so through the magic of technology, I will go ahead and find out the other percents and put them in for you as well. So if you wanted to check your rounding and your ability to write things in percents, you've got those two answers to check with. And we're going to move on to creating a conditional contingency table, conditioning on the type of driver. So this means that the type of driver is the thing that we want to have sum up to 100%. We want to divide by these totals. Just like I showed you when we talked about gender and major. So we're going to use the drivers as our totals that we care about. So I'm going to go ahead and scroll back up because we don't have enough space to do that here and do it besides our original graph, our original table. So our original table, let's redraw this. We have our student and our staff drivers. We have our American cars, our European cars, and our Asian cars. And then we'll go ahead, I'll leave our total categories. It's fine. So if we're going to actually calculate it, our American cars, there's 108 of them. And we want to condition on the type of driver. So we want to have all of these students add up to 100%, all of these student drivers. So we're going to divide by the total number of students. And we're going to do that for everything in this column because we're conditioning on student drivers. And the goal is that we'll get out 100%. And we're going to do this exact same thing for staff, except for with 104 staff drivers, we're going to divide by the total of 165 until we get all 100% of the staff drivers. Now we do not need to do the overall total column, but there's nothing wrong with doing that. If we want to do that, we're going to divide by the whole 362 in this column. So I'll pause you and then, of course, with the magic of a time lapse, give you the actual percents. All right, so there's our table. A question I could ask you after seeing a table like this is basically the same question we asked with the gender and major. Is there a relationship between the type of driver and what car they're going to have? And so for this one, what you'd want to note is, my answer is yes, because if you look especially at the American and European cars, it appears that students are more likely to drive European cars and staff are more likely to drive American cars than the other group. Asian cars seem to have a similar breakdown, but those two look like they're a difference. And I realize this is a little subjective at this point, so a nice little rule to use is if that difference is greater than 5%, you might want to say that there's a relationship. But like I said, we're going to have an objective way and some numeric ways to measure this later in the course. So not a question I ask very often. My questions are much more focused on these 1, 2, and 3, maybe 4. The last thing to mention here is just those displays for our categorical variables. We saw the split bar chart. This is like when you would have the student and the staff, like we saw with the race and plea deals, and then the students would have their, I wish I knew the numbers, I don't have them in front of me, their different types of cars that they have, and same with the staff. It's terrible, but you get the idea. And then there is a stacked bar chart where you have all the students stacked into one, all the staff stacked into the other. I'm going to glance up so mine is a little more accurate, and then you'd have that bar split. So you'd have, okay, about half of them have American cars. There's a little bit more of Asian cars than European, and then you'd have your European section, right? And you do the same thing for staff, so you can kind of see how this breakdown might be different. For staff, there's a little bit more on the American cars, about the exact same in terms of the Asian cars, and then that European section shrinks a little bit. So split versus stacked bar charts are our ways to display this and sort of look and explore those relationships, and we saw them both in that preview activity.